Okay guys, here's everyone's favorite type of math problem, word problems. So logs show up actually in the real world a lot, in science especially. So a lot of these problems can be kind of intimidating because the verbiage sounds so complicated, but if you can just look at the formula and the variables and kind of tune out, just focus on what's necessary and not what's unnecessary in the problem. So this problem is about sound intensity. So we've got two variables here. We have I for intensity and L for loudness. This I sub O, even though it looks like a variable, is actually given to us. They say that I sub O is about 10 to the negative 12 watts per square meter. Okay, so here, right, I'm really only looking at two variables, L and I. So it's telling me that the intensity of the sound of a children's TV show is half the intensity of the sound of the adult show before it. And they want to know how many decibels does the loudness decrease. So L, we want to know L. And what's a little tricky is that they didn't tell us the intensity, but they did tell us that the adult show has twice the intensity as kids show. Okay, so what I can do there is I can call the adult show, let's call the adult show L of 2I, and let's call the kid show L of I, right? Because whatever the intensity of the kid show, the adult show is twice that. And they want to know by how many decibels does the loudness decrease. So what they want to know is the decrease in loudness. So they want to know what is L of 2I minus L of I. That's what they're looking for. Okay, so let's see here if they want to know L of 2I, well, let's use our formula here. L of I, I'm just going to write in the formula, is 10 times log I over IO. Right? And then the adult show would be 10 times log 2I over IO. So they want to know that. Okay, so now what we want to do, guys, is we want to use our properties of logs here. So first, I want to notice that these guys both have a 10 in common. So I'm going to factor out the 10. Right, so it's my greatest common factor here. Okay, so now what I want to do is I want to use my quotient and product property rules, right? And I want to say, okay, well this is 2 times I, right? So I can say this, I'll keep the 10 out here. This is equal to log of 2 plus log of I over IO. Now I could do subtraction there, but I'm really not going to need it because look what's going to happen right here, guys. Do you notice something interesting? Well, I have a positive log I over IO and a negative log I over IO. So these guys cancel out. So all I'm left with is 10 times log 2. And in my calculator, I can do this in my calculator. And that's going to give me approximately 0.3. And that's going to give me approximately 3 decibels. Now that's a tricky problem. That's definitely not an easy problem. The next one is definitely a little bit easier. The practice problem on the notes is the second one, not the first one, because this is pretty tricky. Okay. If you need to rewatch that, that's okay. You can go rewatch it, right? Because what's tricky here is that I had to use the product property to notice that I could pull the 2 away from the I over IO. And that's definitely a subtle noticing it subtly. This one is more straightforward. So we've got this law called Hicks' law that models basically how quickly people choose items from like a menu, right? How long will it take them to choose will depend on how many items there are in the menu. That makes sense. So the average reaction time for a person can be modeled by this model, right? So N is the number of choices on the menu, and A and B are constants that they're going to be giving to us. So here they're saying A is 4 and B is 1. And they want to know how much longer would it take a customer to choose what to eat if the menu has 40 items versus if the menu has 10 items. So what we need to do is we need to do 40 items and we need to do 10 items. So let's do 40 items. Yeah. So they told us that A is 4, so I'm just going to put in A is 4, B is 1, and then I'm going to do this, right? N is 40. So the 1 doesn't really make any difference here because it's just times 1. Okay, now in my calculator, I don't have a button with log of a base of 2, so I'm going to change the base to a 10. That's what we did in the last video. So if you remember, this is C and this is A. So I'm going to say that's 4 times log 41 over log 2. Sorry, not 4 times, 4 plus. Oops, sorry guys, this is plus. Okay, and if I do log 41 over log 2, I get approximately 4 plus, this turns into approximately 5.4. So it takes a person about 9.4 seconds to choose from 40 items. That doesn't sound likely to me, but oh well. Okay, let's do 10 items. So A is still 4 and B is still 1. So I'm going to do 4 plus 1 times log base 2, and this time N is 10. Right, so again, that 1 doesn't really make a difference. Okay, here I'm going to do the change of base. So it's going to be 4 plus log 11 divided by, and I'll remind you of the parentheses, log 2, which equals this value, if I do that on my calculator, is approximately 3.45. So if I add 4 plus 3.45, I get 7.5 seconds. Okay guys, they want to know the difference. So what's the difference in the time it takes? Well, it's 9.4 minus 7.5, which is approximately 1.9 seconds. Takes 1.9 seconds more to choose from 40 items than 10 items. Okay guys, that's it for 6.5.